So again, we're lucky on this one because your formula sheet does give you a lot of the logarithm formulas right here. And I'm hoping we remember how these work. I think the first one we need to focus on, if I have log base b of x equals y, that's logarithm form. Do you remember how to put it in exponential form? Does anybody remember me doing this? And that looks really cute. So if this is logarithm form, exponential form looks like this. B to the y equals x. So log form, exponential form. And you do probably need to be able to convert back and forth between them. A couple things I want to point out. Remember, adding logs, we can smash them together and multiply. Subtracting logs, we smash them together with a division. The power property, this exponent, can become the coefficient. We just talked about that. We'll talk about that one in a minute. All right. Let's make sure we know how to use our calculator. ln of the square root of 11, really? Square root of 11. Round to the nearest thousandth. 999, whoop, 1, 9. Is that what you got? If you're following along, all right. Logarithm of 26.4. 1.422. Okay, here is a rewrite. We've got a logarithm equation, and it wants us to rewrite it. So remember base to what it equals. So this is 3 to the 4th equals 81. I can double check and I can see, is 3 to the 4th 81? Yeah, so I know I did it right. Rewrite as a logarithm question. And this is one where I kind of like to read what it says. I've got a base of 8 raised to the negative 2 equals this. So if I've got a base of 8, log base of what? 8. Of what number? 1 over 64 equals negative 2. So same thing, a little curly Q. But you've got to remember to add the logarithm in. Okay. Rewrite as a logarithm equation. I do want to put this here. So log base c, which we never see log base c, that is known as the natural logarithm. So it's ln. So if it says to write it as a logarithm and I see e, I should know right away that we're going to use ln. So what's our base? E. So log base e is ln of what? Yep, equals 7. Perfect. Rewrite as an exponential equation. What's our base if we've got an ln? E raised to the y equals 8. Has anybody messed with these calculators enough to see if we can change the base in them? Can we?
Yeah.
Did you use it, or was it easier to just do the problem?
It's not hard. It's the top right button, go straight to base.
Oh, right here?
Yeah.
Okay. All right, so we can type this in our calculator. So right here, this guy right here, lets me fill in exactly what we see. Now, I do, yours doesn't do that?
Yeah, mine doesn't.
We'll have to get it in the right mode.
Yeah.
Remind me and we'll mess with it in a minute, okay? So I can type it in and I get 2. But I could do this quicker without my calculator. That just took me a lot of time. How many 6s, 6 to the what power equals 36? 6 raised to what is 36? 2. So I can do that pretty quick. How about this one? 4 raised to what would give me a fraction? It'd have to be negative, right? 4 times 4 is 16, times another 4 is our, so this would be -3. You could also type that in your calculator if we get it in the right mode, it sounds like. We'll do it, we'll figure it out. Oh, graphing. Okay, Britton says he remembers graphing with me last year, did we? Who knows, that was so last year.
Yes.
So last year. Okay, so Alex likes you to plot 2 points and draw the asymptote, and then you get to hit the graph it tool, and it connects the dots for you. All right? So the crazy thing is this base will change probably every problem. And so you've got to remember that our points change based on what that base is. What does the -1 do to your function? We're used to seeing it maybe out here.
Is it a Y or something?
We're used to seeing it on the, that just shifts it up or down. So in this case, because it's minus, what does it do? Shifts it down. What does the negative do to your function? Yeah, it's going to take it from this direction and flip it, right? So it flips it. Now, this is one that I do like to graph the parent function, and I'll put the points in, and then I'll shift it like in Alex when I'm graphing it. That's the easiest way for me to do it. So let's just make a little table. Based on what we did here a second ago, where is it? Right here. How easy was it to figure out how many 6s are in 36? It was easy, right? We're going to pick numbers for our table that make our life easy. So what's a great number that I could have for x? 2 to the what is 2?
4.
2 to the what is 2? 1. We'll do that one next. How's that? 2 to the, all right. So I'm just doing log base 2 of 2. All right, what's another easy number to put in right there for x? 4 would be a great one. So let's do log base 2 of 4. You bet. So if I let x equal 4, how many 2's does it take to get to 4? 2. One that will always show up, and it's only going to make us graph 2 points, but you can always use when y is 0, x will be 1. Okay? As your functions get bigger, like if we're finding out it goes off of the scale, this is one that you'll use every time. Okay, so if I plot those points, just plotting those points, here is 2, 1. Here is 4, 2, and then I've got 1, 0. Do you guys see where the asymptote would be? Right there. Now, I'm not going to graph it because I don't want to have to graph it and then graph it again because I need to do my transformations, right? So what do I do? Do I do the -1 first or do I reflect it first? Ooh, that was so long ago, right? So I wrote it down for us. Do you need to write that down again so it's in front of you? Or can I just move forward? All right. Oh, taking a picture. That is the quickest way to do notes right there. That was amazing. Good job. Okay, so it says vertical shift is the very last thing we do. Did you get it? I wanted my finger out of there. You don't need to look at my ugly finger. So the first thing we're going to do is we're going to reflect everything. So because this is just flipping upside down, that guy will stay there, right? Oops, I'll fix it. How's that? Thank you. So this guy will stay there. I'm going to do my new function in blue. And this one is here. Yes? So we have flipped it. And now what do we need to do? We need to move all of those down or 1. So right there, I need to move it down 1. So down, down, down. Where would you place your asymptote? Right here. It will not graph it if you don't place your asymptote. And then it will connect the dots for you. Don't forget to go back and erase your points. You'll have to click those all gone. Additionally, give the domain and range. Domain, where do we start? 0 to where? Infinity. My range? Negative infinity to infinity. Good. Good. Unless we've got a horizontal shift on our domain, right? Domain would change, but our range will stay the same. Is that what you're telling me? Okay.
Range always stays the same.
Range is the same on that one. You're right. I'll come write it down. Did you get it? Okay. This one is another base 2, but we're going to move right and up. This one is a base of 4, and we're going to move right and down. Would you like me to do both of them, or do you just want me to go to the one that has a different base? I'm happy either way. You want to see both of them for practice? All right, both of them for practice. Log base 2. So we're going to create our table. Log base 2 of x. What are our numbers that we liked? If x is 2, what's y? And because it likes only 2 points, should we just always use 1 and 0 as our second point? If you don't remember that, pick the next easy number, right? We would have picked 4. So let's plot those points. I've got 2, 1, and 1, 0. Okay, our transformations. What's the first thing we do? Horizontal shift. So which way are we going to go?
Oh.
Here's our horizontal right here. Remember, it's always the opposite direction when it's inside with that x. So we're going to move them here. So now this is gone. This is gone. What does the plus 2 do? Up 2, up 2. This time, where is our asymptote? Which way did it move it? Just moved it over 1. So now it's here. And then hit your connect the dots. Let's look and let's see how it changes with a different base. Questions on that one? Okay, I look like I had a couple eyebrows. Yes, ma'am.
Would the domain be 1 infinity?
Domain would be from 1 to infinity. Yeah, I'm sorry I skipped that. Thanks for reminding me. Yes. How do I find the asymptote? If there's no transformation, it's always right here on 0. And then because we moved everything to the right one, it shifts it right one. The more points we plot, you would see that we get closer and closer and closer and closer and closer and closer to that asymptote, and it becomes more obvious. When there are only 2 points, it's really hard to see. So that's actually a really fair question. All right, next one. Our parent function on this one is log base 4 of x. What's the point that we decided that we like every single time?
1.
Is that 1, 0?
Yeah.
All right, so what do we want to pick for x that makes our math easy? If my base is 4, we want to plug in
16.
lower. We could use 2. Is 4 an easy one though?
Yeah.
Because we've got log base 4 of 4, which is just 1. All right, let's plot those points. We've got 1, 0, and 4, 1. The more of these you guys graph, the more you'll see the pattern. Does it bother you that the -3 is in front of the function?
No bad.
Yes.
A little bit. If it does, kill it and put it down there. Is it a plus or was it a minus?
Minus.
All right. Put it at the end if it bothers you when it's in front, okay? What is the first thing we do? Horizontal shift. Which way are we going? If it says a -1, what are we doing? The opposite. We're going to go right 1. And then our vertical shift is at the end. And what does it say to do? 1, 2, 3. Down 3. Those are gone. Where is my asymptote? What did I do? I moved everything to the right 1. And then you can just hit the connect the dots tool. I've got to make that really big. I missed it. I hope those logarithms just come screaming back to you. Let me know where you need help. I do want to help you on those for sure. Oh, thank you.